Welcome to solverfy.
We'll be looking at more problems on friction. Consider the beam shown in the diagram carrying distributed load. I want to determine the force, horizontal force that will be required to pull out the wedge. Now, to solve this kind of problem, it is good practice to bring out the free body diagram, just as you can see from the board. Okay, and you can apply the conditions of static equilibrium to solve this problem. For this one, we can say, let's consider the top part here where we have the beam and the wedge just under it. All right, the summation of moment there about D is equal to 0, so that we have it to be Fa, the frictional force at A. Okay, sine theta, which is sine 10 degrees inclination there, times 7 the distance. Okay, plus the other force Na, which is the normal reaction at A, cos plus 10 degrees. Distance is still 7 minus or our the distributed load. The first part is 4 times 4. Of course, we take it from half of that one down to D, so it's going to give us times 5 as the perpendicular distance. Okay, while for the other part to the left is going to give us half. 4 times 3, of course, we take the third down to D from here, where the 4 meter ends. So we just multiply by 2, so it's going to be 2. So equal to 0. When you solve this, you're going to have your NA. Of course, you put your FA is same as NA mu mu. Your FA is mu NA. Okay, so you just have to substitute the values are given there for mu, which is the coefficient of friction is given. So your NA is going to give you equal to 12.79 kilonewton. Okay, now between the bottom of the beam and the top of the wedge, or the top of the support, you can take your conditions of equilibrium to the summation of the vertical forces, going to give you 0. So when you do that, you're going to have your normal reaction at A. Sorry, this time normal reaction at B. Okay, it's going to be minus normal reaction at B minus, okay, minus FA sine 10 degrees minus NA cos 10 degree is 10 degree is equal to 0. So when you solve this, you're going to have your NB. Of course, again, NA is mu, FA is mu. You are going to have your NB. Of course, FA is mu NB, so you put the value there. So this one is going to give you 13.16 kilonewton. And of course, you can consider equilibrium along the x-axis, so that you have something like this 0. When you do that, you're going to have minus FB Just pick them from the diagram there. FB plus P minus FA cos 10 degrees plus NA sine 10 degrees. So equal to 0. When you solve this, you're going to have your P to be equal to 5.53 kilonewton. So this is the force that is required to pull out the wedge. And of course, if P is 0, will the wedge be self-locking? Yes, because 0 is less than P, or P is greater than that 0. So it's going to be self-locking.